Doing my thing. Okay. So we were just talking about calculations. So we made our assumptions. Everything is good. We're going to plug everything into the calculator. I showed you guys that you can make it match your work if you want to. I press enter, and this number I get is my z-score or test statistic, basically. So what I want to now find is a p-value for this z-score. So basically, if you want to draw a picture, what I've got is this graph, and these pictures are not required, but they might help out at the beginning as you guys are learning these things. Down the middle of this graph is 0 for my z-score, right? It's not away from the average at all. So 1.25 is somewhere over here. I'm basically testing this side of the graph. I want to know the percentage that's at that spot because I'm looking at something being possibly more than 20%. This is what I need to prove to the ad agency to make my money, that I'm actually in this area. Then they'll be happy. So p-value is going to be second vars number 2. Since we're going to the right, our lower limit is going to be the 1.25, and the upper limit is going to be the infinity. 0 and 1 for standard deviation, and hit enter. So this is my p-value, which is 0.1056. So it doesn't tell us specifically what the alpha is in here, but our alpha value, we're going to write it over here so we know, is 0.05. So we're comparing these two now. If this percentage had been less than this, then we could say that this is wrong and that we're going to go with this one. But because our p-value is, 10.5%, almost 11%, all right, it's greater than this 0.05. So what we are going to do is fail to reject the null hypothesis, the HO. All right, so we would reject it. We would say this is false, and this must, this is the one we'll go with if this number was less than 5%. All right, but it wasn't. So we're going to say, it is what it is. And if you forget which way to go, because it is confusing the first couple times you do it, you guys can see down here at the bottom, it tells you. If the p-value is greater than alpha, we fail to reject. If it's less than alpha, we reject. All right, so any questions on the calculation stuff? So here's kind of the steps you need to show as you're going through it. We okay with these questions? Like nobody's in class anymore. Everybody's going, I'm teaching to myself here. You guys good? All right, so now we got to conclude all this up. You got to speak to the executives now who have no clue how to do math, what your conclusion is. Welcome to being a math genius. That's what you got to do. So use the sentence in the notes, and you can copy it word for word, and we'll just substitute things in as we go. So here it is, kind of right here. Sorry, their camera's being weird. So we're basically just going to write this first bullet point here. Since the p-value is, and we're going to say greater than alpha, we fail to reject the null hypothesis. There is not sufficient evidence to suggest that, and we'll write out our thing. All right, so I'm going to put it on the screen, not in written form, so you guys can see it better. All right, so hypothesis, assumptions, p-value, alpha value, There's everything we just did. All right, there's my conclusion at the bottom. It's easier to read the print than me write it up there. So since the p-value is greater than alpha, all right, 10.56% is bigger than 5%. We fail to reject the null hypothesis. There is not sufficient evidence to suggest that the true percentage of people who have heard the ad is greater than 2%. So I cannot prove to the advertising executives that we're doing our job, so therefore we're going to lose this contract. But it is what it is. Life doesn't always give you the answer you want. So that is a hypothesis test. As you guys are writing that out, let me know if you got any questions. Alrighty, so as far as what do I need to know for the quiz on Wednesday, Mr. G, because you said this was kind of a review. This part right here is exactly the same as the quiz on Wednesday. So this is what you start with your confidence interval. So this is for your Wednesday quiz. This is step number 1. This is mostly the same, except our formula is a little bit different. Our formula is going to be p hat plus or minus our z-score that we'll get from the calculator times the p and then 1 minus p and then over n. So this is the formula you would use on Wednesday instead. All right, that'll give you an upper and lower limit. There's my u. To which you will say, we are blank % confident that whatever is between da, da, da. So that's your quiz on Wednesday. But if you guys look, a lot of this is the same stuff here. We're just looking at it from the other side now. We already got a result. So I want to test, hypothesis test, if the result I already got is inside or outside that interval. If it's outside, it's going to be a less than 5%. And therefore, we're going to say, sorry, what you got doesn't fit the interval you're supposed to get. So you're working the other side of this. So some people like the hypothesis test better. Some people like the confidence interval better. But they're both essentially kind of working the same problem, just from a different angle. The confidence interval is saying, before I take any more samples, here's what I think is true. The hypothesis test says, here's what the population says is true. Is it? And we just work it from the other side. All right, again, any questions? All right, I'm gonna let you guys try one then. If there's no questions, chat's really quiet today. So either everybody's sleeping because they wanted the Chiefs to win and they're upset, or something. It's Tom Brady, man. It's gonna happen. All right, try example 2 on your own. Make mistakes. Cuss at it if you want. I won't get too mad, I promise. A little mad, but not too mad. And then let's see what you guys got. We'll go through the answers here in just a second. Okay, so assumptions. This part again will be on your quiz Wednesday. So this part is important that you know first off. So you got to verify that you have a random sample. We do of viewers. Yes, we're good. We got to verify that it's normal because of 2 things, that n times p and n times 1 minus p are both greater than 10. They are, we're good. And then lastly, you have to verify independence. And so the population of people who watch TV is greater than 5,000, we're good. All right, so everything's set. Now we're going to switch to the actual calculations for this problem. All right, so it just shows up at once. Let's walk ourselves through this carefully. Step by step. Don't worry about this part yet. Let's look at this first part. So I got 255 over 500 because 255 people said that they watched out of the 500 people I randomly asked. So that was my p hat. That was my sample. I just went randomly out there and said, Laura got picked. Hey, Laura, do you watch the show on Wednesday now that we changed it? And she's like, yep, or nope, or whatever. That was it. All right, so that was my sample. We're supposed to be at 55%. That was the original one, right? That was our original hypothesis. So we subtract it. And then we divide by the standard deviation, which is the population percentage times 1 minus that percentage over the sample size n right here. All of this into the calculator, however you want to type it is fine. Just watch your parentheses and stuff. You should get negative 1.7979. So do we do okay there? For most of the people I walked around and checked. I accidentally did the same thing Maddie and Claire were doing. We all did this, and Laura did the same thing. We all put 225 for some reason. I don't know why. Maybe I said it by accident. All right, so we were all getting something different. But a negative number is okay. So now I take this number and I plug it into the calculator. So let me show you guys how to do that. And then I'll explain the p-value and all that stuff. So you got your z-score. Now what? Second bars number 2. Since it's negative, we're just going to test the left side. So our graph looks like this. Zero's in the middle. We got this negative 1.79, which is like right here. And so all of this area is on this side. But because we're testing differences, we also have a positive 1.79 over here and all that area. We didn't get this from the formula, but we know they exist because we're using a not equal sign. So it's on the left and on the right. So if it's different at all, being more or less viewers than what we originally had, then we want to know if it made a difference. That's it. So we're not worried about if it's more or less. We just want to know if people stuck with us when we moved, what's the popular show on CBS now? Criminal Minds from Monday to Wednesday. I don't know what you guys want. Because I know Dancing with the Masked Singer or whatever is on Fox. So there you go, same thing. And they move it from Mondays to Wednesdays. Are you still watching it on Wednesdays? That's what they want to know. So you go to your calculator. We're just going to pick, since this is negative, the lower half. So our lower limit is negative 1 E99. And our upper limit is going to be this negative 1.7979. All right, we know that this is it over here. These are supposed to be symmetrical. I'm a horrible artiste, but they're supposed to be the same. So we figure out what the value is here. So there's 0.0361% over here, but since it's the same, we can multiply by 2. So my p-value is actually 0.0722 for this one. Because I have to account for it could be more or it could be less than what we originally thought. We don't know. What did the change on Wednesday do? That's what we're trying to figure out. So anytime it's not equals here, then you have to multiply by 2 down here. If it's just less than, then you do the left side. If it's more than, you do the right side. So my actual p-value, the chance that I'm going to get the sample that I got, is 0.0722. So I had a 7% chance by chance alone, randomness alone, of getting my sample. Well, just do a quick inequality. This number is less than 0.1. So because this is less than, we are going to reject the original hypothesis that the show is the same as it was when it was on Monday. Right? That's all we were doing. So we reject, in this case, the null hypothesis because we were less than right here. So you guys are like at the highest level of statistical analysis now, you know, outside of doing calculus. Like this is the trickiest, most difficult, like most advanced stuff we do. This separates the, you know, freshmen and college doing entry stats from you guys because they don't do this stuff. All right, so since the p-value is less than my alpha, in this case, they told me use an alpha of 0.1. We will explain later in the year why this is important to decide carefully what you want. Right now, just go with what they tell you. I reject the null hypothesis, so I'm rejecting this, and I'm now saying this is no bueno. There is sufficient evidence to suggest that the proportion of people watching the TV show on Wednesday is different from, that's what we're trying to do, than what it was on Monday. We don't know what the actual percentage of people watching it is necessarily. Our sample suggested that it was smaller. So maybe we lost some people because Monday Night Football, you know, or Wednesday night's got something else on they'd rather watch than whatever. Okay. As a TV exec, I worry about that later. As a statistician, I just go, here you go. I'll take my check at this location, please direct deposit, thank you. Or hey, start investing in Bitcoin. I'm just kidding, I won't get off on that. I knew Connor'd laugh at it. All right, so that's the whole idea behind this hypothesis test is you get a sample of 255 out of 500. Does this verify that you should keep this original percentage or it's different? That's all it is. It's just a fancy way of going through it. This is all scientific. So there's 4 steps on these. State your hypothesis, go through your assumptions, do your calculations, and write your conclusion. For the quiz on Wednesday, this part right here in the middle is the part you got to worry about. Your conclusion's a different sentence, but it's the same idea. We are 1% confident, blah, 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 blah. All right, any questions for me before we wrap this up? All right, so there's a lot of stuff here. Please don't wait until like, you know, 10:30 p.m. on Tuesday, the night before, and start working on the homework. I'm so overwhelmed, I don't know what to do. Like try to do some of these beforehand so I can help you guys out. It's very easy to get lost in this stuff because there's a lot of things to do. So you got to stay on top of this unit. These 2 things that we're doing are like the fundamental idea behind all of statistics altogether. So we're in the big leagues now. We've been promoted to the show, and we got to show that we can pitch, and we don't want to wait till the night before to do our exercises. All right, so some things just to remember as we're doing this. Getting statistically significant results means you are rejecting the hypothesis. So I rejected the hypothesis on our last example because our sample size proved statistically significantly that the difference of people watching the TV show was big enough from Monday to Wednesday. So I can go into the boardroom meeting and be like, you guys screwed up. I got a sample that's less than 55%. My results are significant enough to say that because you moved this show to Wednesday, all of those actors and actresses who are making money on being popular are now going to be less popular. Like you did it, you screwed everybody up. Good job, buddy. And if he argues, you can just say, my math is good. If you fail to reject it, meaning your sample doesn't prove one way or another, then that means the difference between these 2, the one that you got and the one that they claimed, is just random change. So we accept in statistics that it's, you know, based on randomness, you may get a sample that's bigger or smaller than the actual percentage. Right? I might have interviewed only the 500 people that don't typically watch TV at all, or just don't watch TV on Wednesday nights anyways, or whatever. Like, I don't know that. Right? Had I failed to reject it, that could have been explained for why it was not that much different. Anyways, that's just a special note at the end, more advanced thinking. The idea is to be able to run and do these tests. So last call, any questions for me? Okay, since everybody's all silent and quiet, they're either super confused or they got it. What we're going to do next is let you guys look